Intermediate Algebra for Statistics, Polynomial Functions. Lesson Objectives. Define the parts of a polynomial function. Add and subtract polynomial functions. Lesson Objective. Definitions. A term is a constant, a variable, or a product of a constant and one or more variables raised to powers. Examples. 3x to the 6 is a term. X, negative 3, x to the 1/2 power, and negative 2x to the 3rd, y to the negative 5th are all examples of a term. Terms in an expression are separated by addition and subtraction. A monomial is a term, a variable, or a product of a constant and one or more variables raised to counting number powers. Sometimes this is known as natural numbers. Let's look at some examples. This is a monomial, 3x to the 6. 6 is a counting power. X is a monomial because it has a power of 1. Negative 3 is because it has a power of 0. So x to the 0 power is 1, and 1 times negative 3 is negative 3. And the last example, negative 5 x to the 7th, y to the 4th is a monomial. The powers are counting numbers. A non-example would be x to the 1/2 power. That is not a monomial. Another example would be x to the negative 3 power. Negative 3 is not a counting number. It is not a natural number. A polynomial or polynomial expression is a monomial or a sum of monomials. Example. So this is a polynomial that has 4 terms. The terms are separated by addition or subtraction. This is a 2-term polynomial. So is this a 2-term polynomial. 5 is a polynomial because it's a monomial. So is x. And so is negative 2x to the 3rd. We write polynomials in descending order. So to put a polynomial in descending order, we need to talk about what's called a degree. The degree of a polynomial in one variable is the exponent of the variable. Negative 7x to the 4th has a degree of 4 because that is the exponent for the x term. 2x to the 3rd, y to the 5th has a degree of 8 because this is one term and we add the exponents. So 3 plus 5 is 8. The degree of the polynomial is the highest degree of any non-zero term of the polynomial. So for this polynomial that has 3 terms, this has a degree of 5, this has a degree of 3, this one has a degree of 0. We take the highest, so this polynomial has degree 5. Example 1. Use the words such as linear, quadratic, cubic, polynomial, degree, one variable, and 2 variables to describe the expression. Number 1, we have negative 3x squared plus 8x minus 4. Number 2, we have 5x to the 3rd minus 2x squared plus 9x plus 1. And number 3, we have 6a to the 5th b squared minus 9a to the 3rd b to the 3rd minus 2ab to the 4th. Solution. Number 1, the term negative 3x squared has degree 2. It's the highest degree. Now notice this is in descending order also. Degree 2, degree 1, degree 0. Because this is the largest degree, we say this is a second degree polynomial. And this is known as what we call a quadratic. We will define this in a later video. Number 2, polynomial has 4 terms. So we have degree 3, degree 2, degree 1, degree 0. This is what's known as a cubic, and again we'll define this in a later video. Number 3, so this polynomial has 3 terms. The term 6a to the 5th b squared has a degree 7. It is the largest, so we say this polynomial has degree 7. So we would call this polynomial a 7th degree polynomial. Lesson objective. Combining like terms. Definitions. The coefficient of a term is the constant factor of the term. If you recall, constant just means number. Example, the term negative 7x cubed coefficient is negative 7. The leading coefficient of a polynomial is the coefficient of the term with the largest degree. Example, 3x cubed plus 6x squared minus 4x minus 9. The leading coefficient is 3 because this term has the largest degree. The terms 6x to the fifth and 8x squared are unlike terms, not like terms. We cannot combine these two with addition or subtraction. Example 2. State the coefficient and the degree of each term for the given polynomial. We have 5 terms. So the first term would be negative 2x to the 6th. The next term would be 5x to the 5th. The next term would be negative x cubed. Next term would be 2x. And the last term, the constant term, is negative 1. The coefficients for each of the terms would be negative 2, 5, negative 1, 2, and negative 1. State the degree and the leading coefficient of the polynomial. Well, the degree is the highest, so that would be degree 6. We would call this a 6th degree polynomial, and the leading coefficient would be negative 2. Combining like terms. Process. To combine like terms, we add the coefficients of the terms. Let's look at an example. Combine like terms when possible. Number 1, 5x cubed minus 4x squared plus 2x cubed minus x squared. Number 2, 3p to the third t squared plus p squared t minus p cubed t squared plus 7p squared t. Solution. Number 1, one way of combining like terms is to regroup where you have like terms together with like terms. So if you notice here, we have the x cubes together. So now we add the coefficients. And here we have the x squared terms, and we add the coefficients. And we would end up with 7x cubed minus 5x squared. Now we can't add these two together because this has a power of 3, this has a power of 2. So this is simplified. Number 2, if we rearrange the terms, we have the p cubes t squares together. So we add up the coefficients 3 and negative 8. And we have the p squared t terms together. This has a coefficient of 1. This has a coefficient of 7. So our answer would be negative 5p cubed t squared plus 8p squared t. Adding polynomials. Process. To add polynomials, combine like terms. Let's look at an example. Find the sum 5x squared minus 7ab plus 3b squared plus the second polynomial, which is 2a squared minus 4ab minus 9b squared. Solution. One way to do this is to rearrange the terms. Later in the video, I will show you another way that involves using shapes. So here we arrange the a squares. Here is the ab terms, and here are the b squared terms. Combining the coefficients, we have 7a squared minus 11ab minus 6b squared. And we are finished. Subtracting polynomials. The process. To subtract polynomials, first distribute negative 1, then combine like terms. Example 5. Find the difference. This polynomial subtract this polynomial. So we have to distribute this negative to every single term in the second polynomial. So we will have negative 1 times 6x squared, negative 1 times minus 4x, and negative 1 times a positive 1. So that will become negative 6x squared. This will now become plus 4x minus 1. Now we combine like terms. So if we group these together, here's the x squares, here's the x's, here's the constants. We have x squared plus 2x plus 4. Example 6. Find the sum. Now for this example, I'm going to use shapes. So my x cubes will be rectangles, my x squares will be ovals, my x terms will be triangles, and my constant term will be a trapezoid. So I can combine my rectangles, and this has a coefficient of 1, this has a coefficient of 3, so that'll make 4. So we have 4x cubed. This has a coefficient of -6. This has a coefficient of +5. So the ovals added up will give me a -1x squared. Next, 2x and -4x make -2x. And then we bring down our constant term, which is 4. And we are finished. Example 7. Find the difference. This polynomial subtract this polynomial. Now our first step is we have to distribute this negative sign to every single term for this polynomial. This is a positive 3x cubed. It will become negative. This positive 5x squared will become negative. And the minus 4x will become plus 4x. Our next step is to combine like terms. My x cubes will be rectangles. My x squares will be ovals. My x's will be triangles. And my constant is trapezoid. So for the x cubes, we have 1 plus -3, which gives us a -2. X squares will be -6. -5 becomes -11. And 2x and 4x make 6x. And we bring down our constant term, +4. Thanks for watching.